Jai Bharat to all students. In last lecture we have started probability. Okay, then we have discussed different types of probability, in which we have discussed independent event, dependent event, and mutually exclusive event. Okay, in that lecture we only discuss basics of different types of event, independent and dependent. Okay, but in today's lecture, first of all we will discuss in detail about independent event. Okay, then mutually exclusive event, and then we will discuss about dependent event, conditional probability. Okay, so these three types of event we will discuss in next our three lecture. Okay, so it's important, so you get better ready for this lecture also. Okay, so independent event, we already discussed about what is the independent event, and already discussed about example on independent event, tossing a coin, throw a dice. Okay, so first of all let's rewind some of the what is the independent. Then we will discuss how to find out a probability of different types of independent event. Okay, so first of all let's get a quick revision about independent event, then we will discuss more about independent and its example. Okay, so definition we already know, dependent and independent. It words itself said dependent means it depends on others. Okay, so depend event means where what happens depends on the what happened before, such as taking card from a deck makes a less card each time. Okay, so it's depends on other. If we pick up one card from the 52 number of card, then now if you want to choose a card, there are less card available to choose from. Okay, so probability will change. It's depend on other what card this will choose, so it's called dependent. Okay, but independent events means it will do not depend on others event outcome. Okay, so independent event are not affected by previous event or previous outcome. Okay, it's not depends on previous result. Okay, okay, you toss a coin and it's come heads three times. We already seen this example. Okay, if you toss a coin and let's say it's your bad luck, and you every time you say tails it become heads. Okay, so heads came three times, but now what is the chance of that next one toss will also be? It will always be 0.5 or 50%. Okay, it does not depend on how others result previous result are be there. Okay, if it is a 7 times head, 10 times head, 50 times head. Okay, but next heads and tails probability will always will be 50%. It will not depend on the previous all other outcome. Okay, so this is independent, it does not depend on the previous outcome or previous result. Okay, so now how to find probability of different independent event. Okay, we already know how we can find probability of any event. Okay, but now let's say we have to find out probability of two event, three events. Okay, merging of two event, three event. Okay, more than one event. Okay, so now let's say these two or three event is independent, then we have to solve like this. We will see next in our lecture. Okay, now let's say if it is a dependent event, then it's a next other formula. Okay, let's say it's a mutually exclusive event, so there is also other formula. Okay, so last formula of probability, it's only about one event. Okay, but now let's say two event, three events are there, and we have to find out the probability of all them two or three event. Okay, so how do we calculate? Okay, so first of all, probability of independent event. Okay, we already know what is the probability of only one event, number of ways it can happen divided by total number of outcome. Okay, just like say probability of getting a head, it's a 1 by 2, and probability of getting a 4 or 6 is a 4 or 6 is 2, or number of total outcome 6, 2 by 6, 1 by 3. Okay, we already seen this graph. If its probability is 0, said it will not happen in the futures. It is impossible. Okay, 1 in 6 chance is unlikely. Your probability of 1 by 2 is even chance. Okay, likely is 4 by 4 in 5 chances, and certain, if probability is 1, is certain. So always probability goes from 0 to 1. Okay, now this, if you want to find out two or more event, probability of two or more event. Okay, so this formula already we discussed is of only for one event. Okay, number of way it can happen upon total number of outcome. But now let's say we have to find out two or more event. Okay, so let's say probability of 3 heads in a row. 3 heads in a row. So now we have to toss a coin 3 times. Okay, so there is a heads. It's a what is the independent event. Okay, so first of all you have to identify that this event is a independent event or dependent event or mutually exclusive. Then you can follow the formula and how find the probability. Okay, so tossing a coin is a independent event. It does not depend on previous outcome. Okay, let's say if we toss a coin head. Okay, so what is the probability of head? 0.5. Okay, now let's say second coin is tossed. Now what is the probability of both coin is a head? Okay, so how do you find the independent event, probability of independent? Okay, so you have to multiplying the chances. Okay, formula is the only multiplying the outcome. Okay, so what is the probability of one is head and second is also head, so it's a 0.5, it's also a point. You have to multiply both of these probability. Okay, so there is a 0.25. Now in question they have asked 3 heads in a row. Okay, so 0.5, 0.5, 0.5. Okay, and multiply by 0.5, multiply by 0.5, so 0.125. Okay, so chances of getting 3 heads in a row is 125. Okay, or you can say that 12 percentage. Okay, you can always identify as a percentage, 12.5 percentage. Okay, so these are the three independent event. Now if you want to find out the probability of 3 independent event, then you have to multiplying the particularly chances, multiplying the particularly probability event. Okay, so each toss coin has a 1 by 2 chance of being head, but lots of head in a row, it's unlikely. Okay, so you can see that probability here is a 5 by 2, 0.5, but for getting 3 heads in a row, is probability will be decreased. Okay, we already know that 3 heads in a row is uh, unlikely. Okay, now let's say 7 uh, heads in a row, it's somehow impossible. Or okay, so it's like this. Okay, so let's say that it's unlikely to get say 7 heads in a row. Okay, when each toss a coin has a 1 by 2 chance of being head. Okay, so what is the probability of 7 heads in row? We have to multiply by 7 times. Okay, so 0.0078125, less than 1%. Okay, so there is a less than 1%, that's that if you toss a coin 7 times, then its outcome will be 7 heads in a row. Okay, in a row. Okay, and now this is the same question as a question 2. Questions 2 is said when we have just got 6 heads in a row. Let's assume that we have got 6 heads in a row. What is the probability that the next toss is also head? It's always 1 by 2. Okay, next toss is does not depend on previous outcome. Okay, but if you want to find out 7 heads in a row, 7 tails in a row, okay, so it's a probability like this. You have to multiply the all the outcome of particular event or probability of particular event. Okay, notation, how do we note it? We use P to mean probability of. Okay, so independent event P of A and B is equal to probability of A multiply by probability of B. Okay, let's say let's solve different example. Your boss, to be randomly assign everyone on extra 2 hours work, everyone extra 2 hours randomly. Okay, on weekend means Saturday and Sunday, and evening, weekend, Saturday, Sunday and evening. Okay, between 4 and midnight means 4 to 12. Okay, 4 to 12 for extra 2 hours, not all 4 to 12 hours. Okay, extra only 2 hours. Okay, in between Saturday and Sunday. Okay, so what is the probability that you will get pick? Okay, or what are the chance you get Saturday between 4 and 6, Saturday and between 4 and 6. Okay, so now let's say there is a Saturday 4 to 12. Okay, Sunday 4 to 12. Okay, in this we have 4 slot, 4 to 6, 6 to 8, 8 to 10 and 10 to 12. Okay, so Saturday 4 slot are available and Sunday also 4 slot are available. But what are the they have asked what are the chance that you get Saturday, and in that Saturday you will get the slot as a 4 to 6, extra 2 hours. Okay, so we have to find out about this event. Okay, now first of all, let us the start with the day, Saturday and Sunday. So there are 2 days on weekend. Okay, so P of Saturday, you have to probability of Saturday you will get that it's a 0.5. Okay, one Saturday, Sunday is 1. So probability of you will get chances on Saturday is 0.5. Now timing, you get the Saturday. Now timing, you want the 2 hours of 4 to 6 out of 8 hours of 4 to midnight. 4 to 12 means 8 hours. Okay, you have to get the 2 hours, extra 2 hours. Okay, so what is the probability of 4 to 6 you will get chances on Saturday is 2 by 8. There are 2 hours and total 8 hours, so 0.25. Now choosing a Saturday and choosing a time, it's a completely independent. It does not depend on other. So we have 2 probability. Okay, so both of these event are independent. So if you want to combine, you what are the chances you get Saturday between 4 to 6, you have to just multiply. Okay, so probability of Saturday and timing is 4 to 6 is a probability of Saturday multiply by probability of 4 to 6.5 multiply by 0.25 means 0.125. Okay, so 12.5% chance that you will get a timing slot of Saturday and 4 to 6. Okay, so this is how independent events works, and how this is how probability of independent event you can find. Okay, let's say another example. The chance of flight being delay, is 0.2, 20%. Chance of flight being delay. What are the chances of no delay on a round trip? Okay, if this is a origin, this is a destination. Okay, flight is flying from this. Okay, for chances of flight being delay is 0.2%. Okay, time does not reach the destination. Okay, here origin, here destination. Okay, but they have asked what are the chances of no delay on round trip. Okay, not only one trip but round trip. Okay, so there are also a possibility that there is a delay in flight. It's also 0.2. Okay, if it is a origin to destination or destination to origin, it's the same flight. Okay, so probability of delays remain same, 0.2%. Okay, but they have asked no delay. Okay, now this probability is of chances of being delay. Okay, so first of all we have to find out not delay. Okay, complement. Okay, so it's a 1 minus 0.2. Why? Because total is probability of 1, so chances of flight not having delay is 1 minus 0.2, 0.8. Okay, so now for the round trip, okay, so there is a 0.8% chance that it will not delay. Here also 0.8% chance. Okay, so both of this is independent event. Yes, if it flight is delay in first trip, and after return it will not delay, it will happen. Okay, so it will does not depend on the outcome of previous result. Okay, so it's a independent event. Okay, so now we have two event, and probability of no delay is 0.8, and also other trip 0.8. Origin to destination, destination to origin, we have to calculate round trip, that's why. Okay, so 0.64, 64% chances that there is a no delay in the round trip. Let's say chances of first flight delay. Okay, so chances of delay is 0.2 percentage, and second flight will remain in time, no, there is no delay in second flight. Okay, so it's a 0.8. So 16% chance that first flight will be delay. Also same as a return flight, for first flight no delay 0.8, second time delay 0.2, 16%. And now let's say both flight will be delayed, 0.2 and 0.2, 0.004. Less chances that both of these flight will be delay on a round trip. Okay, now let's, if you assume add all the sum, then we always get a 1. We already discussed that probability of all the outcome and summation of it is always going to be 1. Okay, so there is a 64% chances of no delay. Okay, one more example. Imagine there are two groups. A member of each group gets randomly chosen for winner circle, and then one of these gets randomly chosen to get the big money prize. Okay, two groups, and we have to select from one group to winner, one group winner, and after two member we have to choose, randomly choose a winner, so they will get the money prize. Okay, so there are basically two event is there. There is a 1 by 5 chances. Why? Because there is a 5 member. Okay, there is a 5 member. Okay, so it's a 1 by 5 chances that you will get as a winner. Okay, it's not about race or any competition. Okay, it's a randomly chosen. Okay, they have given the word randomly chosen. Okay, so there is a 1 by 5 chances of going into the winner circle. Yes, and after winner circle there is a 1 by 2 chance. Why? Because there is a only two people, so 1 by 2 chance of winning the big prize. Okay, and this, both of these are what is independent event. Okay, so if you will choose as a money prize, you have to multiply it, probability of these two event. Okay, so 1 by 5 followed by 1 by 2 chances. Okay, so there is a 1 by 10% chances that you will get the money prize. Okay, 0.1% means 1 by 10%. Okay, okay, so this is a independent event. Okay, let's quickly revision of independent events. Okay, why? Because dependent events is somehow lengthy topic. Okay, so today we will not start a new topic of dependent event. Okay, so quickly revision of this independent event. So in that next lecture we will start with first of all mutually exclusive event, and then after that we will start with the dependent event. Okay, conditional probability, or you can also say that. Okay, so independent events does not depend on others. Okay, it's not affected by previous outcome. Okay, if you toss a coin, it's come up heads 3 times, what is the chance that next toss will also be heads? It's always going to 50% or 1 by probability is 1 by 2. Okay, it does not depend on previous outcome. And we if there is a one event, then probability of event happening is number of way it can happen and total number of outcome. Now if you want to find out two or more event and probability of that two or more event, then we have to first of all identify that this two or more event is independent event, it is a dependent event, or it is a mutually exclusive event. Okay, so for 3 event there is a different formula to find out the probability. Okay, so first of all you have to identify that this is these 2 event or 3 event is independent, then you can use this formula of multiplication. Okay, formula of multiplying independent events, you have to find out the formula of by multiplying the chances. Okay, now probability of 3 heads in a row. Okay, if it is a 1 heads, it's a 0.5. if it is 2 heads in a row, you have to multiply 0.5 into 0.5, so it will be 0.25. or let's say 3 heads in a row, 0.5 multiply by 0.5 multiply by 0.5, so it's a 0.125. okay, so if you increase the heads in a row, that will decrease the chances of getting happen. Okay, so it's not possible that you will get the 10 heads in a row, probability will be less. Okay, so 7 head in a row is a less than 1% chances that this event will be happen, 7 heads in a row. Okay, and Saturday notation is P of A and B is equal to P of A multiplied by P of B. Okay, for short term notation. Okay, then we have discussed example on Saturday and Sunday and extra 2 hours for 4 and midnight. Okay, so there is a, first of all you have to choose Saturday or Sunday, so it's a 0.5 possibility. Then in which Saturday there is a 4 gap, 4 to 6, 6 to 8, 8 to 10 and 10 to 12. Okay, so getting the 2 hours of 4 to 6 out of 8 hours in 412 is also 2 by 8, or you can say there is a 4 slot and you have to pick up 1 slot, you can say that 1 by 4. Okay, it's the same as 0.25. okay, so now we have 2 event and both of this event is a independent event because it does not depend on the other event outcome. So we just have to multiply and overall probability is a 0.125, or you can say 12.5% chances. Okay, for delaying in a round trip, there is a 64% that no delay will be happen. Okay, 0.8 into 0.8. if first flight will be delay, it's a 16%, and return flight delay is also 16%, same. Okay, then both of flight delay will be 0.004, 0.2 into 0.2. okay, so chances of delay is 0.2, that's why we have to write down 0.2 into 0.2. and if we add all the outcome, event of all the outcome, it always going to 1. okay, so now this is your assignment question. Okay, you have to find out independent event of both these. And you have to write down in the book and upload it in RNWIET application. Okay, so now today's lecture is completed.